Hi, today I'm going to be talking about what plasticizers are and the current controversy surrounding their widespread use. So to talk about plasticizers, first I'm going to have to talk about polymers. So what is a polymer? Well, polymers are large macromolecules made of small repeating units called monomers. So an example of a monomer is a chloroethene molecule, otherwise known as vinyl chloride. And this is represented by this circle here. Now if we were to join together two of these monomers, we'd get a dimer, three a trimer, and if we keep going we get these large chains that are just called polymers. In this case, this would be a polyvinyl chloride chain. And these polymer chains can be anywhere from 10 monomers long to thousands. Now an important property of polymers is that they have two different solid states. The first is when the polymer is at a very low temperature, where it is very hard and solid, and this is because the polymer chains don't have enough energy to move, and this state is called the glassy state. And the second state is when the polymer has been heated enough that the polymer chains have enough energy for partial motion. This allows them to be flexible and soft, and this is called the rubbery state. And the temperature at which a polymer transitions between the glassy and rubbery states is called a glass transition temperature, denoted by Tg. So the glass transition temperature of a polymer controls a lot of its properties, so it's important to be able to control this temperature. For example, if you want something to be soft and flexible, like a plastic bag, then you need the polymer to have a low glass transition temperature, and vice versa. So what affects the glass transition temperature of a polymer? So there are a number of factors that affect this, such as backbone flexibility, side chain rigidity, chain stereochemistry, chain interactions, and chain length. But the one that we're going to focus on today is the use of plasticizers. But what is a plasticizer? So a plasticizer is an additive that is added to polymers during a process called plasticization. It essentially lowers the glass transition temperature of a polymer, making it more flexible and durable. Plasticizers can either be added internally or externally. Internal plasticization involves the plasticizer being used as a co-monomer and being added directly into the backbone of the polymer chain. The plasticizer is usually a monomer with a lower glass transition temperature and can cause branching to occur, increasing the distance between the polymer chains and weakening the intermolecular forces that need to be overcome to transition to the rubbery state, lowering the glass transition temperature. An external plasticization involves the plasticizer being added to the polymer as an additive. It does not directly bond to the polymer chains, but is held in between the chains by intermolecular forces such as hydrogen bonds and van der Waals forces. This, similarly, increases the distance between the polymer chains, again weakening the intermolecular forces between the chains and lowering the glass transition temperature. External plasticization is the most commonly used. The most commonly used type of plasticizers are phthalates, which are a type of plasticizer used with polyvinyl chloride, or PVC, due to high affinity to PVC. They are esters of 1,2-dibenzene dicarboxylic acid and are produced by an addition reaction with alcohols of varying lengths to phthalic anhydride. And this is their general structure. They are classified into two different groups based on their molecular weight, which depends on the number of carbon atoms on their alkyl side chains and the length of the alcohol used in their production. Phthalates with larger molecular weights are considered high phthalates, and those with smaller molecular weights considered low phthalates. Low phthalates are less commonly used as plasticizers as they are more volatile, although sometimes this is advantageous, such as in perfumes or paint. Three of the most common high phthalates are di2-ethyl hexyl phthalate, or DEHP, disinonyl phthalate, or DINP, and disodecyl phthalate, or DIDP. Phthalates are odorless and colourless and can add a lot of durability or flexibility to PVC, so they're very useful for PVC products, and some plastics can contain up to 50% of phthalates by total weight. And because of the extreme versatility and usefulness of plasticized PVC and consequently phthalates are used everywhere. Most items people use in everyday life contain phthalates or other plasticizers. For example, footwear, gloves, cables, car seats, lampshades, Tupperware, perfume, and even in children's toys, which we discuss later in the video. However, whilst plasticizers are very useful, their use has also been very controversial. This is because external plasticizers, which phthalates are not bonded directly to the polymers, so slowly leach out from the plastics into the air, our food, drink, and other surfaces. Phthalates have also been found in our blood, sweat, and urine, according to a 2012 study by the Scientific World Journal, suggesting widespread phthalate exposure and potentially some bioaccumulation. This has been the cause of a lot of controversy, as phthalates have been claimed to increase the chance of breast cancer, type 2 diabetes, infertility in males, and many more concerns, including asthma and allergic symptoms and impaired neurological developments in children. Many studies have been taken into the potential harmful effects of phthalates, some suggesting negative effects, and some that the current exposure levels are safe. One of these studies was conducted by the Environment Health Perspect on if a link could be found with phthalate concentrations in urine and breast cancer. Urine samples were taken from 233 women with breast cancer and 221 women without in northern Mexico, and the concentrations of 9 different phthalate metabolites were measured from March 2007 to August 2008. Overall, the study found that women with cases of breast cancer had much higher concentrations of MEP, but their controls had much higher concentrations of MCPP. These results may seem to link exposure of diethylphthalate, which is the parent phthalate of MEP, to increased rates of breast cancer, but also seem to suggest a negative correlation to MCPP's parent phthalate. Another similar study was submitted by the Journal of the National Cancer Institute on a potential link to postmenopausal breast cancer in 2019, monitoring 419 women with cases and 838 controls. Urine samples were taken to measure the concentrations of 13 phthalate metabolites over 1 to 3 years. Overall, under many different conditions, there were no statistically significant correlations found between phthalate metabolite concentration and postmenopausal breast cancer risk. Although the study did find that phthalate concentrations did vary a lot on different days for the same person. And as this study had a much higher sample size and took place over a longer period of time, it would be affected by this variation much less than the previous study, so it would be more accurate. However, there are still many studies conflicting results on this topic, and research is still very early to make a definitive conclusion. One potential weakness of these studies, however, is also that they only measured urine samples, which would not account for bioaccumulation, which has been suggested to take place by other studies. One major topic of controversy, however, has been the effect on young children. Researchers at the University of Calgary in Canada conducted a systematic review of the current literature on the link between phthalate concentrations in urine and children's development. They screened 2,804 abstracts and reviewed 11 different studies results, and found that the literature supports the idea that high exposure to phthalates before birth can cause cognitive and behavioral problems in children, such as lower IQ and problems of attention. Further research needs to be done, but due to these studies, and a lot of concern with phthalates being in children's toys, in 2009, the US prohibited concentrations greater than 0.1% of the IMP, the IDP, and the NOP in children's toys. This was later extended to 5 other phthalates in 2018, before later removing the prohibition on the IDP and the NOP, deeming them safe. Other countries have also issued similar bans to phthalates in children's toys. Research of exposure of phthalates to rats and other animals has shown them to have harmful effects, but it is still very debated if we're exposed to phthalates at a high enough level for them to be of any risk to us. As although we are constantly surrounded by phthalates, they do leach at a very slow rate, as they are held in place by strong interactions to the polymer chains. Many government scientific agencies and regulatory bodies worldwide have concluded that phthalates used in commercial products do not pose a risk of typical exposure levels. However, research is still new, and due to many conflicting studies, attempting to lower phthalate exposure may be advisable, especially around young children and pregnant mothers. Some ways to do this are to store and heat food in non-plastic containers and clean up dust regularly, as it has been found to contain phthalates. Thank you for watching.